Hello guys, welcome back. This is your online tutor, Pro John Mandona, tutoring you in science. So before we actually begin, I want us first to subscribe to this YouTube channel. I want you to support this YouTube channel, subscribe, make sure you invite your friends so that they can also learn. So let us dive into chemistry. In chemistry, we are actually going to discuss what we call the Bohr's model of a hydrogen atom. So let us describe the concept that Bohr made in this requirement. So as we dive into today's lecture, we need to understand certain few concepts that we are supposed to know. And the concept is about what we call a photon. What is a photon? A photon is actually described to be a quantum of light. As electrons move, they actually emit energy in form of photons. In our last tutorial, we actually discussed to say that as electrons transition from a high energy level to a lower energy level, that electron will emit energy, and that energy is actually emitted in form of light, in form of photons, to say. So in order for us to actually determine or to calculate this amount of energy that is released, it can either be released or gained. I will revise through that quickly today. we we actually use the formula which says energy is equal to h, which is the Planck's constant, multiplied by the frequency. So let us get to understand some key areas that we're supposed to know. So we need to know that energy is always measured in joules. Joules as the SI unit for energy, h, which is the Planck's constant, and the Planck's constant is actually equal to 6.626 multiplied by 10 to the power negative 34, and this is measured in joules per second. Uh, the frequency V, symbolizing the frequency in this case, is the radiation absorbed or emitted. It depends actually. Uh, C will be the speed of light. I'm going to show you how it is applied. And we actually have the lambda, which is the wavelength of which is the wavelength of that light which is being absorbed or emitted. So the other thing that we are supposed to know is the formula for frequency. In order for us to calculate the frequency, we need to know that the frequency is equal to the speed over the wavelength. This formula is actually coming from speed is equal to the wavelength times the frequency, and we can actually make the frequency the subject to the formula, giving us this particular formula that we have, which is V is equal to C over the wavelength. V as a frequency, C as a speed of light, and lambda as a wavelength. So to conclude, we can actually say that energy is equal to, this is a final conclusion, we can actually conclude to say, if we actually replace this V, replacing it here, since we already know to say that the frequency, that is the frequency, and if we replace the frequency with this thing that we have here, we are actually going to have energy is equal to the Planck's constant times the speed of light divided by the wavelength. So this is our formula that we can use. We can also use this formula here, depending with the materials that I have given you to that particular question. So we need to know that when a hydrogen atom absorbs a photon, it makes an electron to experience a transition to a higher energy level. For example, if an electron is on the first energy level, n is equal to 1, it means to say that when it absorbs the photon, it is going to become excited and it will transition to the second energy level, which is n is equal to 2. But that doesn't mean that it will only transition to that. It can transition from the first energy level to any energy level that is higher above it. The other thing that we're supposed to know here is that if at all it loses a photon, if an electron, an atom loses a photon, if it is quantized, it means to say that it is going to lose energy, a photon, sorry, and that electron will experience a transition which will make an electron to move from a higher energy level to any lower energy level depending on the type of energy that has been lost. So one thing that you're supposed to know is that electrons emit energy in form of a photon. As we earlier discussed what a photon is, these are just packets of energy emitted. It can be emitted or absorbed as a radiation, which is light. So now let me actually give an illustration here. So a simple illustration that I can give here is that we have this hydrogen atom, and we already know to say a hydrogen atom actually has one electron, and this one electron can actually move on any energy level depending with the type of energy that it receives or releases. So assuming to say that this atom has been quantized and it has absorbed energy, so which means energy is going to go in that particular direction. So it means that this energy, this electron is actually going to receive, it's actually going to experience a transition, and it is going to move in any direction or in any energy level. And we already know to say that this energy level here is n is equal to 1. So since that's the energy level that we have, so this energy, this electron is going to experience a transition, and it is going to move from this electron, and it will actually move to any energy level. In this case, it will move to the fourth energy level, and as it moves to the fourth energy level, that is where it's going to be. So here we're going to say that the energy as per the photon has been absorbed by this electron, and since it has absorbed the energy, it means that the energy is going to be positive. The energy is going to be positive. The opposite is actually true as well. The opposite is true. So the opposite is true when we say, I'm going to use a different ink to say maybe the electron is here, the electron is on a higher energy level. So if it loses energy, it means to say this electron is going to lose energy, so energy will be released. So if it loses energy, it means that the energy is going to be a negative. So since the energy is going to be negative, it will transition from a higher energy level, and it will go to any lower energy level depending on the type of energy that it has emitted, and it will land on this particular. In this case, with my explanation, this electron moved from the fifth energy level and went to the second energy level, and as it went there, it lost energy in form of a photon, and the energy will be represented having a negative. This means to say that it lost energy. So that's the thing that we're supposed to know here. So we are supposed to know something here, and that thing that we're supposed to know here is that as electrons move, they actually move and fall to a particular energy level. And in this case, if an electron moves from any higher energy level and they all land on the first energy level, which is n is equal to 1, this particular series is known as the Lyman series. And if any electron moves from any higher energy level and lands on the second energy level, this particular series is known to this particular movement is known as the Balmer series, and it lands on n is equal to 2, the second energy level. And if any electron moves from any higher energy level reaching to the energy level which is n is equal to 3, the third energy level, this particular movement is known as a pass-change series. So any electron can be from, maybe let's say it can come from here, or maybe it can come from here, or maybe it can also come from here, depending as long as they are all landing in the same energy level, which is n is equal to 3, it is past chain. Any energy, if an electron is coming from any higher energy level landing to energy level 2, it is known as the Bowman series. Lehman series, any higher energy level to that one. We also have the bracket series. The bracket series means to say that electrons are coming from any higher energy level and landing to energy level n is equal to 4. Those are the bracket series. I'm going to give you there also in the next presentation. And we can have the last one, which is the fund. This means to say that it is coming from any higher energy level. Energy levels can proceed. It can proceed just like that. So if at all it is coming from this energy level going to the 60th energy level, this is actually known as the fund energy level, the fund series. So let me tell you what I was saying. The transition from any higher energy level to the first energy level, the Lehman's, from any higher energy level to the second, the Balmer series, from any higher energy level to the third, the Paschen series, from any higher energy level to the fourth energy level, the brackets, and then from any higher energy level to the fifth, the fund series. So now let me give you a simple representation here in form of energy. Since we have actually talked about the energy being absorbed and the energy being emitted. So here in this representation, I want to actually discuss with you something. Given to say that you have A, n is equal to 1 to n is equal to 3. Let me delete that one. Okay, let me release that one. Okay, let me just try to just give a presentation without writing it. Okay, so what I'm trying to say here is that in form of energy, how is energy associated with this series that we have actually said? So I'm not going to draw an atom in form of a circular rims, but I'm going to draw an atom. I'm going to actually draw straight lines. That is definitely not a straight line. So I'm going to draw a straight line. I'm going to try by all means to draw a straight line. So we have that particular straight line. We have that one. We have that one. We have that one. I don't know why lines are going like that. I do not know why lines are going like that. I think I cannot manage. But anyhow, I hope you're going to understand what I'm going to say. So this is the first energy level. This is the second energy level, the third, the fourth, and the fifth. So what I'm trying to say here is that as you go away from the nucleus, which is the central part, the energy level starts coming or drawing closer to each other. So which means to say that the energy that is going to be required for an electron to move from this position, the second energy level, to the first energy level, is actually going to be much higher than the energy that is going to be associated from this for an electron to move from that energy level to that energy level. I'm going to explain this deeper in our next lecture. But for now, what I can say is that thank you for listening and I hope you enjoyed this lecture. Don't forget to subscribe, please. Thank you very much. See you in the next lecture to continue where I have ended.